and dips can be found at an amusement park with rides such as roller coasters, or on the road, or you driving over a hill or through an underground tunnel. At the top of the loop, what's keeping your object moving in a circular motion is your FC, which is your centripetal force, and the centripetal force is net force. So in a loop, all your centripetal force is pointed to the inside of the circle, so you would have your Fn, and then you would have also your Fg. So that would equal Fg plus Fn equals your centripetal force. This is our real-world example of loops. So you have your Hot Wheels car driving through the loop. At the top of the loop, Fn and Fg are pointed towards the inside of the circle. Fn and Fg are equal to Fc, which keeps the object in circular motion. At the bottom of the loop, Fn, which is your apparent weight, has to be greater than or equal to the force of gravity so that the object can complete the loop. Fn minus Fg equals Fc. Newton's law of gravitational force states that any two objects in the universe are attracted to one another with equal and opposite forces. She and I are demonstrating this by moving closer together at the same rate. The equation to find this is G m1 m2 over r squared. G is the gravitational constant, which equals 6.673 times 10 to the negative 11. M1 and M2 are the masses of your two objects, and R is the distance between the two objects. Fg is directly proportional to M1 and M2, but is indirectly proportional to the distance squared.
Orbital velocity is what keeps things in orbit. This is a crucial factor for NASA because we don't want things such as the International Space Station or satellites crashing down into Earth or getting lost in space.
When the radius of the string is smaller, the orbital velocity is faster. When the radius is bigger, the orbital velocity would be smaller. So, orbital velocity is determined by an equation. So the equation is V equals square root of G times M divided by R, where G is the gravitational constant and M is your mass, and R is the distance between the two masses. For example, a satellite must have a specific speed in order to maintain its orbit. This is determined by centripetal and gravitational force, which is this equation.
When we are talking about period, we are talking about the measure of time an object takes to do one rotation. That is a measure in seconds. While the frequency is the distance an object rotates in 1 second. This is measured in hertz. These are inverses of each other, and since they are inverses, if the frequency goes up, then the period will go down, and if the period goes up, then the frequency will go down. You find frequency by the equation 1 over t, with t being the period. And you find period with the equation 1 over frequency, with f being the frequency.
A real-world example of the period and frequency is the Earth rotating around the Sun and the Earth rotating about itself on its axis. The Earth takes 1 day to rotate once on its axis, which is approximately 86,400 seconds. We also know that while the Earth is rotating on its axis, it is moving around the Sun, and that takes about 365 days, which we know is a year. In this 365 days, this is approximately 3.15 times 10 to the 7th power seconds. In this year, the Earth travels about 9.4 times 10 to the 8th meters. Since we know these are inverses and have already gone over the equation for finding period and frequency, we know that you can find either the period or the frequency by putting 1 over the period to find the frequency, or 1 over the frequency to find the period.
Centripetal force is the net force acting on an object in a circular path. Since it is a net force, we never draw it in a free body diagram. The reason why it's called centripetal force is because the word centripetal means center seeking. This is because the force acting on the object is directed towards the center of the circular path. Some real-world examples of this is the aviator ride at Kima, tetherball, or like a yo-yo.
The equation for centripetal force is Fc equals mv squared divided by r. Your m being your mass, your v being your velocity, and your r being your radius. Your centripetal force is always pointed to the inside of your circle. The centripetal force in the bucket example is the tension force in the string. The bucket has to be spinning fast enough so that the water can stay inside the bucket.
In the car demonstration, friction is your centripetal force. Friction is what's keeping the car in circular motion. If the road was icy, there wouldn't be enough friction to keep the car moving in a circle.
That picture was retarded. Can you just stop after this?
Okay. Okay.
You're doing great, sweetie. Okay.
Orbital velocity is orbital velocity.
Orbital. Orbital. Okay.
Orbital.
Take 15 million trillion.
You're doing great, sweetie. Keep it up. Another Chris Jenner. She's like, you're doing great, sweetie.
Period inverses are inverses. Period inverses are inverses.
Okay, we're good. Okay, we're good. We're good. We're good. We're alive. Okay, we're good.
Oh my god.
Give me. Ow, my pants. Oh my god. I for real think the chicken is burning on the pizza. I mean, on the grill.
We're taking forever.
Pull it together, Emily.
I'm sorry.